Hello everyone, welcome to the session Programming for Problem Solving. Myself Navya, I am an assistant professor from the Department of CSIT, Nirmala Institutions of Technology. In today's session, we are going to see single dimensional arrays. The overview of the session is, we are going to see what is an array and what are the types of an array, how to declare an array, what are the array subscripts, or how to do the initialization and how you are going to refer the arrays, and using for loop for sequential arrays, and what are the parallel arrays. Coming to the array. Array is nothing but if I want, for example, if I want to store the value, I am going to store the value using I equals to some 5. I can store only one value, right? If I want to store 100 numbers, how should I take the 100 variables? No. The concept that the problem to solve that thing is about an array. So an array can store multiple values at a time on one name. So you can say an array is a group of objects, pictures, or number of columns and rows. So here these are some of the examples. Coming to the arrays. So we can define an array. An array is a special type of variable which can store multiple values of same data type at a time. And array is a collection of similar data elements stored in a contiguous memory allocation with a single name. So we can say array is a container which can hold multiple values of same data types in a contiguous memory allocation. So coming to the types of array. There are two types of arrays. One is one-dimensional arrays and second one is multi-dimensional arrays. So we will call the one-dimensional arrays as linear arrays, and multi-dimensional arrays, one of the type is 2D array. So coming to 1D arrays. One-dimensional arrays are used to store the list of values. For example, if you are going to some shopping, so what you will do, first you will list out the numbers, list out to-do list of that particular day, or in that particular shopping, what are the things you has to buy, you will list on it, right? So similarly, that is called as a one-dimensional array. So here we are going to store the list of values of same data type in one variable. So in other words, we can say the data is stored in a linear form, and those are called as one-dimensional arrays or linear arrays or simply 1D arrays, or we can call it a single dimensional arrays also. So here these are some of the examples of dimensional arrays. First one egg tray consists of number of same type of eggs. One pencil box, color crayons box. For example, pencil box or crayons box. What it consists of? All types of crayons, same type of crayons, right? Books. In a bookshelf, what you will have? You will have all the books. In a chocolate will consist of all the slices of chocolate. And in a piece, green piece, you will have the piece in one shell, under one shell. So that is known as arrays or one-dimensional arrays. See, the abacus also is one of the example. In one particular string, you will have all the same type of buttons. So this is what all about one-dimensional arrays. When it comes to array subscript is an integer expression placed inside square brackets. So after the array name, we will refer to specific number. So array name of the array followed by subscript. So array name is nothing but name of the array, and subscript will hold the index values, and this must be integer values only. Coming to the declaration of an array, how you are going to declare an array is, we are having a general syntax of this. So data type, array name, and size. Here you have to give the size of an array, which is if my variable or array wants to store up to 60 values, then you can give size as 60, like int roll number 60. So here roll numbers is a variable which can hold 60 values of integer data type. So how the memory location would happen here? Here 60 into 4 bytes of memory. In previously, integer value was 2 bytes. So I has given here 2 bytes, but now as of updated compilers ID is we are having 4 bytes of memory. It will store up to 240 bytes of memory. So coming to the initialization. Initialization, how you are going to initialize this? The syntax is this: data type, array name, and followed by size, and you will have the values inside this. So like this, int marks of 6 equals to, you can write 6 marks, or you no need to mention the size is also okay when you are giving the values. Okay, when you give like this, how it will store? Let me show you that. This is marks 89, 90, 76, 78, 98, 96, 86. So this is the marks is a variable name. These are called as index values, and these are called as values of the variables. And coming to the addresses. For example, if it was 100, it will be 104, 108, 112, 116, 120. This is how the starting addresses of this particular memory of that particular index. Sorry, array values. Coming to referring 1D arrays. How we are going to refer the index values if I want to access? In this, if I want to access this element, how I can access this? Simply I can write the array name followed by index value in the subscripts. So marks of 2 equals to 99. So when I go with marks of 2, the values in this, which is 76 or whatever the thing you have, that will be printed. Or if I want to have, I want to change the marks of 2 as 99, I can change it like this. Coming to the using for loop for sequential access. So we are going to use for loops in order to have. So if I am having an array can hold some number of n number of elements, right? So there I can, what I'm saying, if I'm holding 60 values, how I have to print it? Should I print it a of 0, a of 1, a of 2, a of 3 like this? No. So we can use for loops for the sequential access. To read and print in the forward direction, you can use this one. For I equals to 0, I less than n, I plus plus. For the reverse printing, the backward direction, I equals to n minus 1. Why we are taking n minus 1? Why not n means? As the index values will always start with 0. Always starts with 0. So the ending value of the array will be n minus 1. Next, computing the average, sum value or average value, you can have it as like the sum plus equals to a of I. When it comes to the searching or finding maximum or minimum, you can use if a of I greater than max. So this is how we will use for loops for sequential access. So what were the points you have to remember for the one-dimensional arrays? Index always starts with 0. So the first element is a of 0. And condition in a loop, you have to write for sure I less than size. You should not write I less than or equals to size. So to avoid the boundaries, a of size is invalid here. You can write a of size minus 1. For the sequential access is an efficient way to traverse. And reverse access, you have to start from size minus 1 to 0. So coming to, let us go with a small example program of an array. So how I have to take is, this is my array. Array can hold 100 values and number of elements I am taking as n, and I is for temporary value in order to access the for loop. Okay, so first I have to take the value of n value, number of values, size. Okay, then for I equals to 0, I less than size, I plus plus, So I'm reading the values from the user, that number of values, and next for printing. The same you have to print for the for loop also. Sorry. So I'm giving the I want to read 5 values, so I'm giving 5 here. I'm giving the values, 5 values, 1, 2, 3, 4, 5. So what are the values to be printed is 1, 2, 3, 4, 5. See, this for I equals to 0, I less than I plus plus. So I equals to 0, I less than size I plus plus we have used in a forward direction to print. When you go for this one, I equals to reverse order, I want to print in reverse. I equals to size minus 1, I should be greater than or equals to 0, and every time I should be decremented by 1. So I minus minus. So when I execute, so I want to read 5 values here. One, 2, 3, 4, 5 values. See, I has got in a reverse order. This is how to print in a reverse order. We have to change this. So if I want to do the sum of all values, so I have to take sum also. Sum equals to 0 initially. Now at here itself you can have this sum plus equals to a of I. You can have close it. I want to print the sum value. Sum equals to sum. So I'm reading 5 values. Same 1, 2, 3, 4, 5. So what was the sum value I have got? 15. So this is how the array will be read and written. So this is how we have seen in this particular thing using for loop for sequential access, and these are the points to remember we have seen. What are the parallel arrays? Coming to the parallel arrays, if 2 or more arrays that are logically related by their indices, not physically connected like a 2D array, but in simple terms we can say that elements at the same index in each array represented related data. So parallel array is a set of arrays where each array holds one attribute of related data and the same index corresponds to single entity. So going with this, for example, if I am having roll numbers 3 and their marks, so 101 has got 85 and 102 has got 90 and 103 has got 78. I don't have any relation between these two, roll number and marks, but if I am writing for this roll number I have got this marks, is specifically not related, but it was related. So not in one particular array, 2 different arrays, but we are going to relate each other. So this is called as parallel arrays. So these 2 arrays share the same index to represent one student. These 2 indices. This is students 1 data, this is students 2 data, and this is student third student data. So what are the advantages of this is easy to organize it related data, and it is useful for searching, sorting and displaying records. And here the limitations are we don't have any direct relationship between arrays, 2 arrays, but must manually maintain this index consistency, and it becomes hard to manage when data grows large. and the structures are usually better than the complex data. Let us go with a small example program of this. So the same thing. Roll numbers are I'm taking. I'm going with 3 students roll numbers and marks M. Okay. So only 3 students, right? No need of this one. We need only I. I less than 3. So we are going with roll numbers first. Simultaneously, we are reading the marks also. Okay. So while coming to printf, we'll go with the printf also. We'll use this format specifiers. So with this case, it will read the 3 student value, roll numbers and marks. Similarly, it will print it. Okay. So I'm giving the student, first student roll number is 1 and he has secured 98 marks. Second student, he has got some 96 marks, and third student he has got some 85 marks. So when it comes, see here, the student roll number and marks. Okay, let me go with this new line before itself. First student has got some 95. Second student marks is some 68 and third student is some 85. See, the roll number 1 has got marks 95. The same, it will come under same. It was physically not related, but roll number 3 has got 85. So this is how we can relate manually using parallel arrays. So this is all about parallel arrays. Coming to the summary of the session. What is an array? Array is a variable which can hold multiple values of same data type in a contiguous memory allocation. When it comes to the types of arrays, how many types of arrays are there? 2 types of arrays. One is single dimensional arrays and multi-dimensional array. In this session, we have seen the single dimensional arrays. So, how we are going to declare a single dimensional array? So, you can declare the single dimensional array like data type, array name, followed by subscripts. In subscripts we are having size. So here we can take it as int some x of 5. Like this we can declare. So this x can hold 5 values at a time, and the index values already start. The index values are from 0 to 4. Okay, and it can hold 5 values, and memory is 5 into 4, which is 20 bytes of memory. Coming to array subscripts, whatever the thing you have written, the index values what you are writing, we will write in the subscripts, our array subscripts. If I want to access, for example, if my array is like this, these are the values and these are the index values. So if I go with x of some 3 equals to some 9. So I am changing this. X of 3 is x of 3 index value, that would be changed to 9. So whatever you write as subscript value, the index value, that will be changed as it is. You can go with the individual also. And next is an initialization. How you are going to initialization value? Like this, sum at the time of declaration only we have to initialize the values like this, or you can use like this also. Anyone is okay. Coming to referring arrays, how we are going to refer the arrays? So we are going to use referring arrays is nothing but we can refer the arrays by using index values. And next, using for loop for sequential access, we have seen the lot of programs here. So this is what all about the single dimensional arrays in this session we have seen. Thank you everyone.